Okay, starting bi-weekly contest, 138 in a few seconds. Let's see if this is as hard as some previous ones. Alright, find the key of numbers. What do we got here? We're given 3 positive integers, num 1, num 2, num 3. The key of num 1 is this one. There's a 4-digit number such that if any digit is less than 4 numbers, it's padding with leading zeros. The ith digit, taking the smallest digit among the iths. The output is 0. Oh, I see. So let's just do pad all of these. So num1, string 1. Let's just do for num and 1, 2, 3 as this. So we want to do string num, and we want to do the length of string num is less than 4, and we want to do 0, or let's just do 4 minus the length of num. And times 0 plus string. Right, so this whole thing will be here, and then we'll do as string append. This whole thing here, right? Let's make sure that's right here. Unmatched. My syntax is off today. Okay, so I got all these, and basically we just go through and new equals. It's this, and we'll do for I in range 4. We'll do new num equals the min of int. This is a very tedious problem. String 0 I. Let's just do this whole thing. And convert this to an integer. Right, and then we'll basically just turn int new concatenate. Okay. Let's see what we got. We got output 0. Here we got 777. Then here we got 1. Let's submit. Cool. Hash divided string. So we're given a string s of length n and an integer k, where n is a multiple of k. Okay. Task is to hash the string s into a new string called result, which has a length of n over k. So first divide s into n over k substrings equal k. Okay. I think characters have these small hash values. Okay, so we're just basically, it gives us the algorithm basically, we just need to hash it. So let's split up this string into segments. Okay, so the current equals 0 for I in range S with current K. Then we do what if we just do actually this? We do for I in range S, go from 0, length of S, and go up by K. We can do segments append S I plus K. Okay, so that worked. Now what we want to do is for segments, I want to go through all the segments, and basically what I want to do is calculate a hash value. So the hash value hash is 0 for calculating segment. What we want to do is hash plus equals word of character minus 97, and then at the end we want to do total hash 0. Oh no, wait, no. So once we get this, we want to do hash value equals 6, and then result equals word character hash value will return results. So you should get BF. Oops, that's not right. Well, let me look up in the table real quick. That should be right. That should be plus 97. So we got BF, and we got I. Submit. Perfect. Let's go to 3. Find the number of good integers. We got a hard. Alright, let me read through this. So we're given two positive integers n and k. An integer x is called k palindromic if x is a palindrome and x is divisible by k. Okay. An integer is called good if its digits can be rearranged to form a k palindromic integer. So for example, for k equals 2, okay, so what's our constraints? Very small. Is this just probably backtracking? Yeah, so the constraints are very small. So return the count of good integers. An integer must not have leading zeros. So this is really a backtracking or like a digit DP kind of thing. So I'm thinking like if we have a count of all the all the digits, you can kind of just backtrack through and like place them all essentially. Just try different combinations. Yeah, so what if I do, so we're given n, oh wait, no, so we're not given the number, we have to figure out the number of elements. Oh, I see. So we're given x is divisible by k. It can be rearranged to form a k with palindromic integer. Okay, so this one's already a palindromic. So really what we want to find is the number of, so palindrome has at most one odd occurrence of a character, right? So kind of what I'm seeing is this works because we have at most one odd, at most one odd. So I'm thinking like, say we want to make n equals 3. What if we generate all of the different ways you can place, so say we want to make character to 3, we can place 1s, 2s, 3s, 4s, 5s, 6, 7, 8, 9s, and 0s, right? So potentially what we're doing is we're going to say I, at this point, can place any 2 of these. So my, like there's some kind of combinatorics where it's like, I know I can place any 2 of these characters, and once I place the new becomes n equals 1, right? We have a subproblem where we're trying to place one character now. So to place this one, so when we get here to this case, do we have to check? Like, where do we do the check? Or do we have to do something? Can we just do this at the end? After we've generated all the numbers, can we just like do that? We just want to try every combination of numbers. This is interesting. So the constraints are really small. What's the last problem? We're given an integer power and 2 integer raised damage and health. Bob has n enemies for enemy. I will deal. Well, they are alive. So we want to attack enemy 3. The first 2 seconds. So which one has more accepted? So this one seems, they're both pretty hard. So this one seems more doable. This seems like dynamic programming. So we essentially want to like just randomly pick which one we want to eliminate, or is there some kind of logic to determine which ones you want to eliminate? Um, so we pick enemy 3 here, but would it not make more sense to pick enemy 8? Right, because we'd be getting, let's make another section for this. So if we do from the back, right, we'll do 10, we get 10, but then we're eliminating 4, so we get 6, 6, 3, 3. This is 20, 32, 36, 39. So this is also 39. So let's look at this other example. So if we pick the ones with the most, so we'll have 4, 4, 4, 4, 3, 3, 3, 2, 2, 1. So we have 16. Okay, it looks like in this second case, we actually want to go from the front, right? So we would do, we would basically have 4, we'd have 3, 3, we'd have 2, 2, 2, we have 1, so we have 4, 6, 8, oh, this is 19, maybe my math is off somewhere, 1, 1, 1, 1. 4, 10. These are both pretty hard. Okay. So attack enemy 3 in the first 2 seconds. Example 3. Okay, so let's look at this example. Attack enemy 0. So we'll have, yeah, so we have 4, 3, 3, 2, 2, 1, 1, 1, 2, 2, 2. So we have 4, 7, 10, 12, 14, 16, 17, wait, what? 10, 16. So we could either, so what if we did that ordering for the first one? So what if we did, we got, okay, so in the first second we get 10 damage, but we take out enemy 1. So the next thing we get 5, we get 9 damage, another 9 damage. If we take out enemy 2, then we get 7, 7, and we get 4, 4. This is 10, 19, 27, I think, or 28, 28. 28 plus 14, So this is like 40. Okay, so there's no like real greedy way to do it, which I'm guessing means this is probably dynamic programming. But how do we do it exactly? So I guess we could, like, so say for example, each turn we're gonna go through all of these enemies and just for each one do recursion, which I think would be way too slow. I don't think that's gonna work for this. For this, yeah. There must be some other sort of algorithm that we could use. Wow, these are tough. Holy crap. Where I'm at in the standings right now. This is kind of crazy. Pretty high. Maybe focus on this one, it's a little easier. Every second after the enemies deal damage to Bob, chooses one of the enemies that is still alive and deals power points of damage to them. So, like, can we just simulate all of these? So we have to make a choice, right? We have to make a choice. Which makes me think it's DP, right? Because based on our choices, when we make an attack, we're technically solving a different sub problem each time. But I think due to constraints, we can't do DP, right? So is there like a way? So let's look at this example. So we have power equals 4. We have our damage equals 1, 2, 3, 4. And then we have our health equals 4, 5, 6, 8. So we know that it's going to take health divided by 4. So we're going to take health divided by power hits to kill, right? We know this. And then once we know this, let's call this like K or whatever, we know that the damage that can be dealt is K times our damage. So if we have our K times damage, the max amount of damage that they can inflict would be 4, 8, and let's just actually K in this case, 1, 2, 2 times damage, 2 times this is, so this is, you can deal at most 1 damage. So 1 times 1 in this case, you can deal 1 damage. This is 2, we're going to round up. To round this up, so this is actually going to be our K, let's have this here is 1, 2, 2, 2. So we'll have 2, this is 4, 6, 8, right? So this is the total number of damage that they can deal. Let's look at the other example and do the same thing. Right, so we have power equals, it's not an array, it's just an element. Our damage equals 1, 1, 1. Our health equals 1, 2, 3, 4. So our K here is our, so we have 1, 2, 3, 4, right? Because our K is our health, divided by power. Okay. So in this case, health divided by power. Right, and then our K times damage rolls 1, 2, 3, 4. So here it made most sense to start at the end. Here it makes the most sense to start at the beginning. So this doesn't really tell us anything, right? So we attack enemy 3, 2, 0. So it doesn't really make much of a difference here. Whereas in the second example, I want to start from the beginning. Can we do VP here? I think it was like an ideal ordering. Like if we find like an ideal ordering, we can just simulate how much damage we would take. And if not, we just have to do dynamic programming. Um, lowest K value. Like maybe think of some lowest or highest. Right, so if you could think of some lowest or highest value that we could use, um, can we incorporate power into it somehow? This seems very tough. This is like this should be like an 8 probably. Okay, we're second after the enemy is still alive in this power points of damage them. Like, does it ever make sense? Well, I have a question. Does it make sense? It make sense to ever do just one attack on an enemy? Right, to say we have our like 8, 7 power equals 4. This is our health. Does it ever make sense to do 8 first, then go to 7, then go back to 8? I can't really see how. And in these examples, right, we never actually do that. We consistently attack the same enemy. So that makes me think that we just have to figure out in what order we should eliminate the enemies. I guess figuring out how exactly is a difficult part. So if we do maybe damage, so our K is our health over our power. Multiply this. This is the basically number of turns they get times the damage. We want to maybe try by damage first, and then by Oh, so what I'm thinking is like, what if we just try both? What if we eliminate by damage first, and then we eliminate by uh, health, right? So we basically start at either the lowest health or the highest damage. So what if we do this? What if we do for I in range, length, damage, we do P, O, D, and H. So we could do and damage I. We're going to have a tuple essentially that contains both damage I, health I, right? And then let's first sort by health. Min, insert, infinity. So let's do D and H. Let's sort by our key equals can't type today. And the X 0. So this is sorted by damage. So this is comment sort by damage. Then what we want to do is say let's go through and calculate if we do the ones with the highest damage first, right? And we know that our equals sum of damage. Okay, so let's go through this list, and then what we're going to do is for each one we're going to say the total number of damage that we can take is for die DH in DH, right? So basically, the number of damage that we're going to take here is equal to damage from monster equals, so this is 0. So the damage from this monster, why does this look weird? What's going on? Oops. There you go. Okay. So the damage from this monster is going to be equal to D times math ceiling of, right, so this is going to be math.ceiling of H divided by power, right? And then what we're going to do at the end is say min answer equals the min of min answer, or damage. This is current equals damage monster, and then this equals. Okay. Then we're just going to do the same thing, but we're going to sort it by health. We're going to do 1, and then we're going to return. This is just an experiment. I'm not confident this is going to work. We got 19, right? So that's clearly not correct. Okay, and then here we're going to print current damage. Okay. Oh, no, so this is going to be total damage times that, and then we're going to do total damage minus equals D. And here again we have to do total damage equals damage, and then total damage equals 50. Okay. So sorting by health should have worked. Let's also print DNH here. Okay, it's not sorting. Oh, because it's the same. So you either want to do the minimum health or hold on. You just do reverse. Hold on. So this want to be here we got 39, here we got 20, and here we got 320. So those are right, but I'm not super confident if it'll work. Okay, so we get 39, we get 20. Let's see. Damn. All right. So neither of those worked. Why is that? Let's undo our. Let me just screenshot this in case I end up refreshing. So we get 320, 320, 260, 260. So in what order would we want to do this, right? So we would immediately get rid of this, right? So then our first turn we're getting 30 damage, and then we want to do 99 divided by 14. So then we want to do plus 80. So yeah, that makes sense. So we want to do all 4 options. So 4 for loops. Okay, so then we want to sort by damage. What a mess. Sort by damage. Reverse. Sort by health. We want to do sort by health. This is regular sort by health. Yeah, negative somehow. Sort by damage. So we have to redo total damage here. Do total damage here, total damage here. So now we get 110, we get 39, we get 20, 320. Nope. So I should be getting 1172, and then getting 11832. So I'm trying all four options. Clearly, one of these is not quite optimal. Right, so we'll go. So I'm off by exactly 60 right here. So this got an extra turn. Do I want to do about the number of turns they get? Right, so I think this one is getting an extra turn to hit me for 60 damage. Right, so yeah, it's here 11832. Health. Let's see. So we do health. No, so we do 38 divided by 2. 24. Right, which makes sense. So what we're getting is this case. We have 51 divided by 2 equals 26. We have 65 divided by 2 equals 32, 30, 33. And then 48 divided by 2 equals 24. Okay. So in this case, how do we get 1172? So we can do 82. So overall the damage is, the total damage is 82 plus 80 plus 60. So this is 162 equals 202, right? I do my math. 82 plus 80 plus 62. 82 plus 80 plus 60 is 222. Oops. 222. Alright, so we get 222 times 26 do 6. So that equals 5772. So we get 5772. Then we're going to get rid of this 51. So we get rid of this. Then we just have 140. So then we have plus 140 times 33. 140 times 33 equals 4620. So then we just have 60 times 24. So then we have, if we add all this up, we get 5772 plus 460 plus 1440. Right, so which is what I'm getting. Okay, so that makes sense. So clearly there's a different ordering that's better. So what if instead, what if we did 222 times 24? There's 5382. Or is that 5328? Then we're getting rid of, here we get rid of 60. So we have just 162. Then we'll have 162, let's say, times 26. Times 26 equals 4212. And then we'll have just 80 times 33, which is 80 is 2640. all this is 5382 to 8 plus 4212 plus 260. Nope, so this is higher. This is what we got. 12180. Right, so this is what we got here. So maybe what we want to do is the same distance, right? Where we. Okay. So, our total plus 60. So if we do 82 first, so we'll do 2 times 26. And then we'll do 162 times 24. And then we'll do minus 60. Minus 82. So let's do 142. 142. And then we subtract 60, so we just have 82. No, hold on. So we're going to get rid of the 26 first. This is 222 minus 82. This is 140. Right, so we have 140. I'm going to do 140. And the one we did before was the 65. So let's do 140 times 24 to get rid of 60, and then we'll have 80 times 30. Right. So 222 times 26 equals 5772. 140 times 24. 80, 33, 2640. Okay, so we'll have 55772 plus 3260 plus 640. Okay, so that's the ordering. This is how we do it. So this 1772. So we're going to do. So what ordering is this? So we're going to do 80 to 51 comes first. Then we're going to do 60, 24. Then we're going to do 80, 65, right? So this is really not any particular ordering. 82, 51, 60, no, it should be 60, 60, 48. So this is the ordering that we want. So do we always want to start with the one that contributes most to the damage? No. This is a tough one. I'm getting kind of stumped on this, honestly. So what can we determine about this order? Our power here is 2. Power equals 2. So So you know, these are our number of turns each one's going to get. 33, 4, and we can times this by its damage. So this is times 82 times times 80, and then times 60. So let's do 26 times 82. 2132. 33 times 80 equals 2640. And then 4 times 60. 440. Alright, so do these match any order? So first we want to do this, which technically doesn't contribute the most damage, right? So why would we want to do that one first? Could we do the other one first? So why doesn't this work? Let's do, so let's say the number of turns you can eliminate it in, right? Because, yeah. So what we order, so. What if we do, let's try some ratios. 82 divided by 51 equals 607. 60 divided by 48 equals 28. Equals 3, 80. So that's 5 is 1. Wait, what? That doesn't seem right. 1.25. I mean, that kind of works out. That's a downward trajectory. Let's try another example. What if we do the use health? This is damage. 1099. And we'll have 20. So 10 divided by 99 is going to be really small. So it's 0.101, 0.101, and then 20 divided by 3 is just like, what, 6 something, not 6.9. Okay. So maybe the one with the highest damage to ratio. Right. What if we also add our damage to health ratio? So damage by health I. We sort by ratio. So we'll do D and H sort T equals lambda X is 2, and then we could essentially take this. We have 41, already not right. 20, 320, 110. It didn't work in this case. But that's the answer they did it, right? Sort x1. Hold on. To x 39, we get 20, 20, 10. That seems kind of right. Do I try to submit? Ah, damn. Ah, so close. So we want 284, we got 283. The health to damage ratio, health to power. Ugh. A ratio of health to power. Change the ratio to health divided by power. Nope, I already got it wrong. That's wrong. Wrong. That's right. That's wrong. Yeah. Okay, so I think sorting is the wrong approach here. It seems like we're because we keep running into edge cases. So does this have to just be dynamic programming? I can't see how we could do dynamic programming here. X. So we just do this and then also all these other ones. Is this overkill? Just try every single combination. Hold on. 9, we get 20, 20, 110, 1172. Okay, so this just tries every single combination, which I feel like is not right. Try to submit one more time and see if we get it, but I don't think so. Yeah. Shit. So we should be getting 585. Okay, so what would dynamic programming look like here? So we basically have to try every permutation of choices, right? So we'd have to say, well, do we take the first enemy first? Do we take the second enemy, third enemy, fourth enemy? Which one do we take first? And try like every choice, which I feel like is not really feasible here. And my rankings went down a bit lower. People are monsters. Wow. How they do it. So DP. How does DP look here? Okay. So here, total. So I feel like it makes the most sense here to just eliminate this person first. Because you can knock this person out in one hit. So you get 95 plus 94. So you get that your first turn, right? And then the second turn you get plus 94. So you get 95 plus 94 plus 94. So 5 plus 94 plus 94 is 283, right? So that's where that answer comes from. But okay, so 95 over 95 over 23 or 4 over 2. So I'm going to do 5 divided by 23 is 4.134. And then I'm going to do 94 divided by 2 is 47. 47. So it would make sense here to eliminate the smallest. I just want to do it again. So we're literally just trying every single combination. 283, we get 39, 20, 320, 110, 172. Oop. Still doing that one wrong. Okay, so I'm going to stop submitting this because clearly it's not right. I don't want to usually affect my ranking anymore. See if we can figure out something here. But I feel like I'm so close to this. I feel like I'm close, but my solution's also completely wrong. Or in the next 2 seconds, if which enemy one will go down. The number of damage points delta above is 3 plus 3 equals 6. So I just think outside of the box. You use like a binary search in any way. Like what? No, I was thinking maybe we could use binary search like if there's a limit or some value what we want to attack. Maybe like we could binary search for damage or health and prioritize enemies with greater health or damage than that, but I don't think that really makes sense either. Okay. Turn the minimum total amount of damage points to be dealt above before all enemies are dead. So we've seen that there's no real way to prioritize eliminating certain values first. Either there's no way to do it that way, or we just haven't actually found a way that works. We tried doing all 4 combinations, either highest damage, highest health, lowest health, or we've tried ratios. For example, like health to damage ratio. Is there a different ratio maybe? Maybe health to power, health. Let's see, who knows? 283, 39, 20, 320, 110. No, see, that one is wrong. This one is wrong. See, that one's right. Let's try this one. So you get 585. Yeah, that one's also wrong. Okay, so like that ratio doesn't work. Maybe we do, so we had damage over health. What if we do health over damage? Over damage. Right, so we see that's wrong. What if we do damage? We could prioritize damage, health, I divided by power. That's ceiling. Nope. Still wrong. All right, well, I think I'm going to call it here. As you can see, these are two very difficult questions that I don't think I'm going to solve, but I will upload some solutions after the contest. So hopefully this is fun. Thank you for watching.